Welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm Richard Restuccia, Vice President of Water Management Solutions for Jane Irrigation. And today we're going to be talking about the Irrigation Consumer Bill of Rights. And it's a pretty strong title, but I see so much value in what we're doing here because uh, as consumers, we all have a right to know what goes into our products, and more importantly, the quality of the products, and if we're going to get the proper use out of the products that we're purchasing. And oftentimes, we don't have much of an idea of what goes into what we're buying or how it works, or a lot of these things, and yet we're paying thousands of dollars for them. And oftentimes, unfortunately for me, it's a rush decision. I'm rushing to get the decision made instead of taking my time. So one of the reasons I don't take my time is I don't necessarily know at times the right questions to ask. So one thing Cory Broad's done for us and will do again for us today is help us to understand some of the questions you should be asking, how you can really understand what your products are come from, how they should be used, and how to get help with that process all along the line. So I know you've probably seen Cory on here before. He does a great job with his presentations and his instruction. Cory's a certified crop advisor. He was Agriculturist of the Year in 2019. He's a certified irrigation designer. He's got his BS in agricultural business from Fresno State. So he's a local guy. He really knows ag in that area. And then my two favorite things about Cory is one, if you want to see somebody who's really been a thought leader on digital media, it's been Cory. You can find him on LinkedIn. You can find him on Instagram. In fact, it's hard not to find him there. He is out there, and it's really been to the benefit for all of us in this industry. So thank you for that, Cory. And then also, I know how much Cory cares about his customers. If you talk to any one of his customers, they will tell you how much they appreciate the care and the thoughtfulness Cory puts into his recommendations for them, not just on irrigation, but in all aspects of their business that Cory has some expertise in. So Cory, welcome and thanks for joining us again today.
Oh, thank you for that introduction. I know we've done a few of these before, and I really appreciate that and the very kind words there. So, yeah, no, I'm happy to bring up the topic today. And as you mentioned, we've looked at some of this before, and this is kind of the second part of our three-part series on the Irrigation Consumer Bill of Rights. And so without further ado, we'll jump into it and specifically look at the drip and micro irrigation Bill of Rights. I guess I can kind of move through this part fairly quickly as you kind of introduced all that. So I appreciate that. This is from our last presentation as well, but just kind of a roadmap of where we're going. The ITRC, which is the Irrigation Training and Research Center at Cal Poly, created the Irrigation Bill of Rights to do exactly what you had mentioned, Richard, is help consumers, and not just consumers from a standpoint of getting a product and making sure that it works, but a lot of these, especially in the agricultural side, this is a business. And so we have to make sure that we're getting value and maximizing the value out of that. And so over the years, the ITRC has done a great job of taking the Bill of Rights and updating it, and then also expanding it. And then now we have 3 documents. And so as I mentioned before, we went through the general, we're going to go through the drip micro specialty document today. And then hopefully here in a couple of weeks, may have a special guest come in and do one with me as well, and do the soil and plant moisture monitoring systems as well. So again, very specialized into what are you purchasing. So it's not just, again, a blanket document. They've really drilled down on some of the details.
Yeah, it's great, Cory. And I just want to remind everybody tuning in today that we've got both the Q&A and the chat open. So if you have some questions you'd like me to pass on to Cory, just put them in there. And I do want to remind people too that sometimes we don't get to all the questions. And when that does happen, we do follow up with email after, or sometimes a phone call to reach the person. So we do value those questions, appreciate them. We want to get them all answered. So. All right, Cory, let's go.
All right. And so looking at the drip and micro ICBR document, it really breaks it down into 5 categories, and that's going to be filtration, flow rates and pressures, general reduction of plugging, chemical injection, and then general agronomics. Obviously, each of these areas are important to understand. They all add value to your irrigation system and the purchase that you're making. just based on maybe some of the complexities and really what the requirement of the irrigation dealer should be providing. Some of them are going to be a little bit more in depth than others. So you'll see that today as we kind of go through it. And again, as kind of more of a roadmap and a foundation, this is actually a screenshot of the document from the ITRC website. And so again, you can see some areas are a little bit more robust than others. How about that? And so again, they're all really important and do need to be understood. And so we'll kind of go through that with the same scope and focus today.
Yeah, Cory, what a slide, right? There's a lot of words on here, but we can find this elsewhere on the web if we ever want to review it. But just in your experience, which of these areas is the most important to really consider?
Well, and you and I have kind of talked about this in the past through a number of different business conversations, and then also in preparation for kind of this series and kind of the foundation of what we were going to be talking about. And I think that's a great question. And what I really wanted to illustrate is basically adding these arrows and say that they're all interconnected and they're all intertwined. Because, for example, if the filtration unit or system is not operating, maybe that's affecting now your flow rates and your pressures in your field. And maybe that, attacks the general agronomics of it as far as the soil wetted volume in your irrigation scheduling. And then, maybe you're also seeing some issues with plugging. Well, now you have to do chemical injection in order to get rid of that. And so there's just so many things that are intertwined. So when I say that they're all really important, I really believe that, even though general agronomic technically only has 2 bullet points and filtration might have 20, they're all intertwined. This whole thing it's an irrigation system. And so I think it's really important to understand that systems all work together.
Yeah, that's really a good point, right? Each one relying on the other. So you can't have one more important than the other because they're all relying on each other. That's
Absolutely.
a great point, Cory. Thank you.
Links in a chain.
Yeah.
So jumping into filtration, I took some of the bullet points. We won't go through every single one of them, but we'll go through quite a few. One of the first things that comes up is, what is the equivalent mesh size of your filtration unit? So if you're using a screen filter like our Steel Spin Clean, this information is readily available and pretty easy to understand when ordering the product, either as the consumer or the irrigation dealer. We have screens that, 30, 50, 100, 150, 200 mesh. We do custom meshes as well. So there's a lot of options there, but it's pretty straightforward. It's even stamped on the side of the filter. So it's easy to identify. When you get into sand media, it's a little bit different because you have the tank area in and of itself, but then you have the media that does the actual filtration inside. So what type of media is it? And what mesh size effective is that? And so I just kind of did some of the basic setups that we do here in the Valley with the different crushed silicas, and then roughly what those numbers translate to. So sometimes on a bid, you might see as a consumer, number 16 sand or silica. Well, now you know that that's 200 to 150 mesh, depending on the quality of it. And so it gives you a baseline of what you need to do. If you're buying drip tape, you might need 200 mesh. So that might be something you can look at and say, hey, wait a sec, why don't I have number 20 silica in here to provide that extra layer of protection? And so with the media stuff, you just need to be aware of some of those small nuances, because you can change the filtration capacity of it just based on what you're putting inside of it. And then
Cory, we have a quick question on this subject. And is there much difference in price between a number 12 and a number 20?
Off the cuff, I would say no, because it's all based on weights. I would check with your local distributor, because maybe, again, depending on if they buy from different sources or different places, might dictate the different pricing. But from most of the time, I know growers that, they have both types depending on what type of system they have, and it's never come up in conversation. So I don't really see that being an issue at all.
Okay, great. Thank you.
Of course. But one of the things that it might play into is the next point, which is how frequently will that filter be flushing? Obviously, if you put in a very tight mesh, you're going to capture more debris. Therefore, you're more likely to flush more often. And so that's a question that should be answered. People do ask me that quite a bit as well. And I think it's it depends. Some insight should be available from an experienced professional, because every well is different, every water source. If you have a 2-tank system and you're running on the low end of the flow rate requirement versus the high end, there's just so many variables that go in there. But somebody with some insight and understanding of your local area should be able to give you a pretty good understanding. And then, of course, when you have this wastewater, this backflush, where is it going to go? And so to put it in perspective, most of these 48-inch sand media tanks, which you can see pictured on the left, flush about 180 to 200 gallons a minute. So you have to find a place to put that water. And if you can, recycle it, which is great. But remember, it does have a lot of contaminants in it too from a debris standpoint. So being sure to have a place to put that water is really important. And then, of course, I get this a lot too. How often should filters be taken apart? I think simply put, to put some onus on the dealers, maintenance plans should be provided. You buy a brand new vehicle and you drive it off the lot, there's a booklet inside the glove box that's provided for you to say, hey, you need to change your oil at this, you need to do this service interval. I don't think it's unrealistic to provide that information.
Yeah, thanks, Cory. We've got another question coming in. And so what you talked about is flushing the filter, and now you're talking about maintenance. So this person wants to know how often my filter should be serviced and what goes into that service.
Yeah, I think it's a really fair question. A little bit of it is back to it depends. As a manufacturer, of course, I would love it every season if you flushed out the tanks and you removed all the media inside and then put brand new media in. Because over the course of a season and flush cycles, that media is actually fairly sharp at the beginning, and then it gets rounded off over time. And so it loses its effective filtration capacity with that rounding of the material in and of itself. And so every year, if you did it, that'd be great. I don't think that's really common. If you did it every 3 years, I'd probably still be pretty happy, depending on certain circumstances. But again, it should be something that the dealer should be able to do also for you. So you talk about maybe what goes into it. If you're willing to take it on, essentially there's a 4-inch drain port on the bottom of it. And so you have to basically run the system with one of those ports open and try and blow as much of that material out the bottom of the tank. And then you may have to take off the top lids and maybe hose spray on the inside, just kind of depending on the constraints. But it can be a little bit of a process, but most dealers are qualified and have the skill sets to go do that.
Yeah, interesting. So I'm surprised by your comment that every 3 years you'd be happy, right? I mean, I take that as people are going more than 3 years without getting them serviced.
The best story I have on this briefly is there was a grower who was visiting with the salesman one time, and they were having some issues with their system. And to put it into the scope of things, the salesman went and opened up the lid to the tank, and the grower said, "What's inside there anyways?" So that might tell you what you need to know there. So it's again, if you don't know, or you're not educated, or these these conversations today aren't happening, you just won't know. And so it's just an opportunity again, why we're here today, to be able to educate people on saying, hey, let's ask these questions. Let's talk this out now, because it's a 20 to 25 year investment.
Yeah. Okay. Well, that's a good guide. Thank you.
So one of the things that gets overlooked a lot too is, does the pump provide enough water to flush the filter and operate the irrigation system at the same time? And so again, we talked about that 200 gallon a minute, just say, maybe even down to 180. But if you have an 800 gallon a minute irrigation system running, and then the filters go into backflush, you've now added 25% demand to that system. And so if the pump is not set up to handle that, you're going to see low flow in the field, and you're going to see a pressure drop, because that water is now going out through one of those tanks during the backflush cycle. And it's going to happen to the next tank and the next tank until that flush cycle is complete. And if you have excessive flushing, you can actually be really disrupting your distribution uniformity as well. And then your application efficiency of your irrigation, because you're putting 25% of the water for a certain period of time, not even on your field. And so it's really important to manage and understand that, and then also make sure your pump can handle it. And then another way that kind of bleeds into this a little bit is pressure sustaining valves. So there's a separate valve needed downstream of the filters to sustain backflush pressure. Now that doesn't necessarily stop the issues in the field from maybe a lack of water standpoint, because a sustaining valve, what it will do is it will close down and limit some of the water going out to the field to ensure that there's enough pressure and flow going through those tanks during backflush. And so if you don't have a VFD, this is a great investment. And the best way to really break this down simply is it creates more pressure, which means you're going to get a better backflush. And then when you get a better backflush on those tanks, you're hopefully going to backflush less often, because when it does happen, you're more effective at it. And then hopefully overall with that, you end up with less waste with that water, maybe not even being able to be recycled. And so that's a really simplistic way of looking at just putting on, an $800 valve on a $30,000 filter station. I think it's a great investment and shouldn't be overlooked.
Yeah, I think that's great, because you made the point earlier, I think you said 180 gallons to 200 gallons a minute to do the back flushing. And you don't normally do it for just 1 minute. So the more you can reduce that, the better off you're going to be.
Yeah, absolutely. And so that's kind of the concept there. And then what are the initial adjustments necessary for the filter, the station in and of itself, and who's going to make them? I think that's something that kind of gets missed in the contractual side of things, or maybe the discussion with the grower. I think there's this kind of set it and forget it attitude where it's like, well, I'll just throw sand media out there because it automatically flushes and it's better. And then, I'm done, right? I've installed the irrigation system. And so I think just having that conversation up front is great, because again, some growers, they don't even know what's inside there because nobody's ever taken the time to educate them. And so I think as a dealer, it's a great opportunity to show your value and do a value proposition to your customer to say, hey, I'm going to be here to support this. We're going to go through this system together, especially from the onset, to make sure you're running it appropriately and maximizing that investment value.
And I know there's people out there that really pay attention to maintenance and they actually like it, right? They're really driven by it. I'm not one of those people, but I'll tell you one thing I hate more than maintenance or keeping track of it is replacing something before its lifespan is over because I didn't maintain it, right? I hate pulling out that wallet or pulling out that card to pay for it. So I think this is my motivation to pay more attention to the maintenance.
Absolutely. I'm glad I did it. I've done a few maintenance presentations as well. So if anybody needs maintenance tips, please look those up.
Yeah.
So going into the next section, flow rates and pressures, I think it's a fair question to say, what is the minimum pressure anticipated at any given emitter? To kind of put it into context, most pressure compensating drip emitters require about 10 PSI to operate. Many work below that as well. Our top drip and amnon emitters both operate below 10 PSI. So I think it's really fair to say, hey, what's the minimum amount that I need? But also, given this area or constraint, what pressure should I be seeing in this area? Because then if you're performing that maintenance, it gives you an idea or a checklist to be able to say, oh, wow, I am being effective at that. I'm maintaining what the system requires or what we would expect. And then to kind of couple with that, what is the average emitter flow rate and pressure? And that's going to be really helpful in your non-pressure compensating applications. And it also kind of really is kind of the foundation for some of your baseline and irrigation scheduling. Like for instance, if you have a micro sprinkler system, a orange jet at 20 PSI is 8.4 gallons per hour. Well, just say you have maybe a little bit of an excessive hose loss, and by the end of that line, you have 15 pounds. Well, now your flow rate's 7.3. Well, what's the average emitter flow rate in there? And then also that's going to impact your uniformity. So again, it's just a spot check to be able to say, hey, what should I be getting and what should I be looking for? Because then that might trigger you to say, wow, I need to do more maintenance because I'm seeing this change. And then pressure regulators, obviously PR valves are going to be great in your drip tape application. So a pressure reducing or regulating valve to ensure that all of your manifold sections are getting the same amount of pressure and thus water. And then obviously that's going to increase your distribution uniformity. And then one thing that I do see a lot and certainly don't recommend, I believe ITRC does as well, is inline preset pressure regulators on like hose risers and things like that are not really recommended. That's certainly something we want to avoid. And then what is the thickness of the hose and or the tape? It comes up a lot in conversations. Obviously, one of the important things is what's the burst strength, the PSI strength on that tape, but then also what's the longevity of that product, not just from breaking down in the field, but also you got to think about getting it back out of the field, especially on drip tape. It's a foot deep in the ground. You want to make sure that that's as strong as possible and fits your soil and constraints and things like that.
Yeah. Cory, that's interesting what you said about preset regulators and that they're not recommended in a field application. I was wondering why that is.
Yeah, so specific to ag, I think one of the things is obviously, especially on large ranches, there'd be a lot of them out there. And then every one of them is going to have their own inherent variability built into them, just from a manufacturing standpoint. And then one of the things is too, they're really hard to work on because usually they're buried right at ground level. And so if you take them apart, trying to get the springs out or check kind of the flow paths and things like that, it's another maintenance thing that we were talking about. And I'm just not a fan of them. And it's something that we try and avoid. They do wear over time as well. I mean, all products and things do, but it's one of those things that which one's wearing and where is it? And then, really to kind of understand that, you end up having to do a uniformity test anyways.
Yeah. All right, great. Yeah, I get it.
So going into general reduction of plugging, if it's a buried drip system, are the emitter outlets designed to minimize back siphonage, which for us on our top drip and Amnon products, we have AS technology, which is anti-siphon, which means it won't pull water and debris back into the outlet of the emitter. It is available on the market today. It's something that people should look into, especially as they start looking at more opportunities for subsurface drip irrigation in almonds. And then you can see a picture on the left-hand side. That's me flushing a field, maintenance. And one of the things that's important is, are there adequate flush outs throughout the entire PVC part of your irrigation system to clean the pipes before you even put water in your hoses and or your drip tape? And the way I really look at this is, with enough flush outs, easy to do is going to create a better overall maintenance program. You mentioned it earlier, Richard, you don't like doing it, but if I make it easier for you, or if you're a grower and you have your employees, the easier it is to do, the more likely everybody is going to be to follow along with those and get that done. And then something I also see that happens quite a bit is, are the flush outs big enough? Jetting of water, which is essentially turning your hose on all the way, and then when you put your finger over the end of it and it sprays out, you basically push the water farther, but you're limiting the flow rate of the water that's coming out. The same concept happens when you have, say, a 6-inch pipe with a 1-inch ball valve flush out. You're just kind of jetting the water and you're not getting all of the water flow through it, which is what's carrying the debris that you're flushing out anyways. So you go through and you do the process, and then you're still not as effective as you wanted to be. And so maybe you end up having to do it more often, or you're just not effective at all, and then it leads to other plugging and other issues.
So Cory, I can't quite see in that picture, but it looks like it's two hoses coming together. It's some sort of a coupling, and you're breaking the coupling. What's happening there?
Yeah, that's actually going to be a 2-inch PVC ball valve flush out. So this is at the very last riser on the edge of an orchard. And so down that manifold piping system, there are a number of risers, and then this would be essentially the terminal end. So rather than opening up a figure 8 on maybe a drip lateral, this is being able to flush that PVC system. And so what we're able to do here is, you can see a decent amount of water on the ground, but you don't see the water shooting very far out from where I am. And that's because it's sized appropriately for the flow rate that's going to come through. So it's just kind of getting that max flow and not jetting out. And then thus it's pulling the debris with it and cleaning out the PVC system.
Yeah. Okay, great. Thank you.
Yes, sir. Kind of staying with that same theme, has the designer shown the results of a hydraulic analysis demonstrating there will be a hose or tape flushing velocity of at least 1.5 feet per second? That's a lot, I understand. Really, it's about being able to understand is at the end of a hose or a piece of drip tape, so in this case, a lateral, is there going to be the ability to get 1.5 feet per second velocity of that water when you open up the end of it? 1.5 feet is the minimum amount that we like to see when flushing an irrigation system to remove most debris. In other cases, even 2 feet per second may be required, depending on the weight of your material and how much of it is in the irrigation lateral itself. Many irrigation systems I see don't take this into consideration, especially with drip tape, because the size of it around here is 7/8 inch inside diameter, and we're going a 1/4 mile run. So it's roughly 1,280 feet. It's a long ways with a decent sized pipe, essentially. You need a lot of velocity and pressure to get through there. And so, for example, if you use an 18mm hose, 1/2 gallon, 36 inch on an 1/8 mile, which is a very standard run, you're going to need 32 PSI at the riser in order to achieve 1.5 feet per second at the end. And so making sure that the system is zoned appropriately to make that easy, but also is capable of handling it. People size the system for irrigation operation, not for irrigation maintenance and flushing. And so that there's a unique characteristic difference. And we'll get into that a little bit more later on. But one of the final points on this was, if used, can infield filters and or hose screen washers be easily cleaned? And I think one of the things that comes up is just make sure the growers know they're there, or the guys that are in the field, because I had a grower call me a couple months ago, hey, I have no water coming out the end of my line. I'm like, what? And he's like, I have no water coming out of my emitters either. And I'm like, it's the riser screen. He's like, what riser screen? I go over and I take them off, and they were just plugged with some fertilizer, kind of leftover debris and things like that. But essentially it was a small screen inside the riser that was plugging.
Yeah. So Cory, we've got somebody asking about this photo, right? Is this a shock value photo? I mean, that is some really dirty water, or is this kind of common to what you see out in the field?
Well, it's both. I like to hammer points home visually when I can. This was a field call that I was on last year. I was on a drip tape application, quarter-mile run, and they were seeing plugging, and they couldn't understand why. And they said, well, we just flushed last week. And so I said, well, show me how you flush. Well, they have a ball valve, which is one of our NVV09s to make it easier. I was glad that they had that. But this is what they would do, is they would open up the end of the line, and that's as far out as the water would come, because they're flushing during an irrigation operation. They're not flushing in a maintenance specific operation. And so they weren't getting that extra pressure. Thus, they weren't getting that velocity at the end of the line. Therefore, this is just contaminants that are just sitting at the end of the line coming out. You're not really pulling any of the material out. So that's, yes, it is for shock, but I do see it far too often.
Yeah, well, it makes a great point. You know, it almost looks like chocolate milk coming out of the line. You know, it.
Absolutely. So kind of going into a little bit more in depth, as I mentioned earlier, on some of these things. So if you had to do a 2 feet per second velocity on that hose that we were talking about earlier, it's going to take roughly almost 2 gallons a minute to flush an 18 millimeter hose at that velocity. And so if you have a 40-acre field, and I picked a standard almond configuration here, that field's going to require 560 gallons a minute to operate during irrigation operation. Remember, I told you about maintenance operations different. Well, the emission devices are taking water, and the irrigation system needs a certain amount in order to flush. So the emission devices are taking 2.3 gallons per minute per lateral. Then we added almost 2 gallons a minute to the flushing aspect of it. The demand is now 4.3 gallons per minute per lateral flush. And I just kind of picked an obligatory pump curve here I found on the internet. But if we were operating out here in the blue circle area, now, in order to maintain that pressure that we were talking about earlier, we'd be operating back here in the red area during the flush event. Well, that means that we can only run about 350 gallons a minute max in order to maintain that pressure. With that flow rate requirement and what the pump can do for us, we can only open up 82 lateral ends. And again, this is without other friction and other factors involved. It'll actually be a little bit lower than this. But the field, to put it in kind of back to shock value, has 240 lateral ends. That's a lot of opening and closing small sections, because the system may not be laid out appropriately for it. And an example of that, and something that I see very often here, this is a square 40-acre field. This is actually probably about 4 or 5 miles from my house. You have a pump located on the corner. The main line comes down the bottom, and then it just feeds up a single manifold with your laterals coming off going east and west. There's 240 laterals in this field. Starting here and opening up a couple of these, but in order to get the pressure and flow the way you need it, you're probably coming down here and turning off some of the ball valves you have on the riser manually, one by one. Every 22 feet, there's 2 of them going through that process. A simple design change, yeah, it might be a little bit more investment up front, but what if you just ran the main line up here, came in, and then teed off with these yellow squares indicating a valve? Now you can take the full flow rate of that system by turning one valve off, putting it all on one half of the field. How many of these ends can you flush now? So again, just a real life example of a simple investment up front and a simple conversation with the end user, make it easy to do and they'll do it, but also explain, here's the value proposition. Your cost of labor versus the cost of this extra pipe and maybe 2 valves. Here's what you're going to get for the next 25 years.
Yeah, thank you for showing us that solution, Cory, because I was just imagining myself running around this field, turning open some valves, closing a bunch more in 100-degree heat. I'm probably going to skip it today, right? I'll catch it when it's cooler in a few weeks, but providing this solution makes it a lot easier and much more likely to stay on my maintenance schedule then.
Absolutely. So getting into chemical injection is going to be needed in some cases to minimize emitter plugging. I think understanding that and bringing that up front to growers is important. I kind of look at it in 2 different ways. Constant injection, which is generally going to be used for like pH control, getting bicarbonates out of the water, lowering the pH, so on and so forth. And then obviously there's a maintenance style, which is kind of that slug in the material and then let it flush. Obviously, we want to see the fertilizer applications and more of the constant injection side of things. But there needs to be an understanding, can the injection system handle something where maybe we do have some plugging that's gone on in the field and we need to put in a decent amount of material in a short period of time and then be able to flush that out appropriately. So just kind of understanding and making that clear to the consumer, I think is important. And then has the water been tested for its pH, iron, manganese, sulfur bacteria? These things all exist across the US in a number of different scenarios. Certain places have different water quality issues. I think many companies can do that for you outside of just your irrigation dealer. But I do think dealers should offer to take water samples, hopefully partner or have a relationship with a local lab if they don't have something internal that they can offer as well. And so I think just a heads up on that is really important. And then one thing that does get missed quite a bit too is what equipment components can be damaged by injected chemicals. So you can see on the left-hand side, that was actually a barb to a sprinkler at one point. There's not much left at the current state. And so when you think about sprinklers themselves, the barbs, the swivels on fittings, ball valves, those are all made of different types of compounds versus your supply tubing or your PVC. And so understanding what those components are made of and what affects them is something that I believe dealers should bring up, and then also make sure they specify the right products. And then of course, as I mentioned, polyethylene is very resistant to many chemicals. The silicone used in the diaphragms are as well. So, but I think it's a good conversation to have, because you certainly don't want what happened to you, what happened in the picture on the left-hand side.
Yeah, so Cory, you're out there every day. Are you seeing quality issues often? And then if you are, or if you're not, and it's very not very often, what type of issues do you see?
Yeah, I mean, I think water quality comes up. I mean, this year, we all know about the drought and the things that are going on and a lack of surface water. So people are opening up wells that maybe they weren't operating before, or they're running them more than they have before and not necessarily blending the water, if you will. And so in the last, I would say 2 weeks, I've had a number of calls for this emitter plugging, and then we found some iron bacteria. And then, hey, my under drain and my tanks are plugging. How do I treat that? These are conversations that are happening quite a bit right now. I've seen sulfur in water that, the water itself smells like eggs, and then it goes through and basically it dries out almost like the picture does on the left. That was actually an acid attack on sprinkler barb, but where the sulfur has basically dried on the plastic and has dried the plastic out in the process is kind of the best way that I can describe it. And so then it just leaves it very brittle. I actually touched it and it came off like pencil lead on my hand. And so those are the things that you see and you need to be aware of. And again, I kind of talked about that professional local expertise earlier. There are people that operate in your areas that are going to know these things or they've seen them before. So identifying who those people are should be a priority when purchasing a system.
That's pretty interesting. Thank you.
Yes, sir. So getting into the last piece of today, the general agronomic, there's really only 2 things on the ICBR about this, but one that's really important overall is what percentage of the soil volume will be wetted. That's going to influence your soil water holding capacity. It's going to be obviously really important for irrigation scheduling, because you're talking about how much water per foot of soil. Well, you're depending on the per foot of soil, but also the depth and the width of that, right? That's going to give you the volume. And so like an example, drip versus micro sprinkler. And again, it varies on flow rates and soil types, but maybe drip is 20% of the soil wetted area versus the sprinkler is 40%. And the picture on the left-hand side is our 2002 sprinkler, which is pressure compensating on a 22 by 16-foot almond block. And this has our extra long range swivel. And you can see that's certainly a lot more than 40% of the area being wetted. And so just understanding that as a consumer is really important because it's going to affect your irrigation scheduling for the next 20 to 25 years. And then are there any chemical additives needed to minimize runoff? One of the things that comes up a lot in agriculture has been used in the past, on the coast especially, is polyacrylamide, PAM. It gets used in the construction business as well, historically, to basically limit runoff contaminants into sewers and things like that. And basically, it just flocculates liquids in soils and reduces that runoff and pull of soil. Obviously, with a low flow drip tape application, probably not something you really need. But if you have maybe a higher flow, longer range sprinkler, something like that, could be something that could be necessary, but certainly not something we really deal with here in the Central Valley. So in summary, again, all the points are really valuable. I hit almost all of them. And I know we've gone through a lot today. But again, this is meant to create good discourse between the consumer and the dealer and make sure that everybody understands what the expectations are and how we're going to meet them. So if I had to go through and just do a summary for you and give you a takeaway, starting with filtration, does it meet the product need? I talked about drip tape earlier. Some drip tape needs 200 mesh. Other thin wall emitter line needs 120. Most double line drip is 120 to 150 mesh. So most sprinklers are 100 mesh. So understanding what the product application is, we need to make sure that the filtration is meeting that. But also, does it meet your operational needs? If it's something that you have to go through and flush manually all the time, maybe that's not for Richard. Maybe it's something with an automatic type system that's designed well and is a little bit less maintenance intensive. So just kind of understand what the operational needs are there. Pressure, how is it managed in the system? Are there a lot of valves? Are the valves something that take care of themselves for the most part? Is it something that you need to go out and manually adjust a gate valve to continue to operate? And then also, what's the minimum needed for the product or the application that you're running? Because again, that's a baseline. If Richard goes out and he says, oh, I don't have the minimum that I need to operate this emission device, now something's wrong, then maybe it's maintenance. Maybe it's something bigger than that. But you have to understand what that is. And I get asked that question a lot. Plugging, is the system designed with maintenance in mind? Go back to that easy to do method. Injection, have you done a water test? It'd be great to do it before you even build the irrigation system. And then obviously we talked about, are the right materials being used? If you have high pH and you're having to constantly inject large amounts of acid into your system, should you be using certain types of products or certain styles of irrigation? Maybe, maybe not. But those are something you want to look at ahead of time. And then agronomic, how much of that soil are you wetting? And then based on that, does that really design meet the irrigation scheduling needs? Because if you end up saying, hey, you need to run 150 hours a week to meet ET, that's going to be a lot of irrigating. And so just understanding those factors, I think will bode well for everybody.
I was just looking at this, Cory, and I was just thinking, if I was a irrigation dealer, I would hope that every consumer would want to know the answers to these questions, and more importantly, would know the questions. But I think the reality of it is very few do, right? That's why we're doing this presentation, is why you're taking your time to educate. But as a dealer salesperson or a dealer representative, man, if I could help supply these questions to my my customers or help them formulate these questions and answer them, I certainly think I'd be doing a great service to my customers. Do you think that's true? Could you see a way to do that?
Oh, 100%. And that's really, this is about showing the value that as certified irrigation professionals, what we do every day, and making sure that when we looked at those two designs earlier, well, the one that was really hard to flush was probably going to be a lot cheaper to install from a labor standpoint and from a material standpoint. But what is that cost difference? And how can you show people, Richard, I'm designing this with you in mind. I'm designing this around your constraints, and here's how I'm adding value. I think it's again, it's great discourse, and it's meant to be a two-way street. It's not meant to be something that consumers can grill the dealers on. It's meant so that the dealers, and your point, can say, hey, this is why we do what we do, and this is why I'm charging you what I'm charging you to deliver the most value.
Yeah, no, that's great, Cory. Now, if somebody has a question after later on and they want to talk to you, can they call you? Can they email you? Is this okay?
Absolutely. I'm always available. I'm always running around from field to field, unless we're doing webinars. And nonetheless, as you mentioned, I'm always available on social media as well. A lot of people reach out that way. So please come find me, drop me a line, drop me an email. I'll get to you as soon as I can, and I'd be happy to talk to anybody.
Yeah, and this is true. Cory is very generous with his knowledge and his time, always willing to help you out. So please take advantage of that really generous offer. So Cory, great job today. Thank you so much for joining us again for another session. Really appreciate it. I know everyone came away today knowing more than when they started. So thank you. And for all of you out there watching, thanks very much for taking your time today to spend a little time with us on irrigation and water management education. We appreciate it. And always remember, at the janesusa.com/trainings, you can find all our trainings, well over 100 now, as well as we're on Google, Spotify, Apple, iHeartRadio podcasts. You can listen to us as you're driving from job to job or field to field, like Cory is going to be this afternoon. So again, thanks very much, everybody. Hopefully we'll see you back here on Friday, where Andy Ballingary is going to be talking about protecting your most valuable asset, trees, in your landscape when you're doing a turf conversion. So very insightful presentation. So hopefully we'll see you Friday. All right, thanks a lot, Cory, again, and thanks everybody. We will talk to you soon.
Thank you, guys.